Let's look at how the Veolia Sandliner Desanding Hydrocyclone works as one of the key process steps in a produced water treatment system. The purpose of a desanding hydrocyclone is to separate solids from produced water prior to further treatment, to ensure the downstream equipment is protected from erosion and sand accumulation. As you can see, the desanding equipment is located on the left of the walkway, upstream of the de-oiling hydrocyclones on the right. The separation process is based on centrifugal forces and the difference between the specific gravity of water and that of solids. Produced water flows into the central chamber of the pressure vessel, is treated by the hydrocyclones, and exits the vessel via the top chamber. Sand and particles accumulate in the lower sand collection chamber. The hydrocyclones are made from a ceramic material to resist erosion. Due to the pressure differential between the inlet and outlet of the pressure vessel, produced water flows into the inlet ports of each hydrocyclone, which are aligned at a tangent to the inner chamber of the hydrocyclone. This initiates a rotation in the liquid. The centrifugal force, as a result of the rotating water mass inside the hydrocyclone, results in heavier solid particles being forced to the internal wall of the hydrocyclone. Here, the particles move downwards in a spiral motion, exit the liner at the lower outlet, and pass into the sand collection chamber. The desanded water exits at the top of the hydrocyclone via an overflow collector known as a vortex finder. The vortex finder is a smaller diameter axial boss within the hydrocyclone chamber and is designed to allow efficient discharge of the water phase without introducing turbulence and short-circuiting from the inlet flow. The solids which have collected in the lower sand collection chamber can be removed continuously or intermittently, depending on the application. As depicted here, the solids in the lower chamber are periodically removed with the assistance of fluidization. The design of the chamber is important, as it needs to allow both sufficient capacity for the volume of settled sand, as well as providing enough freeboard to avoid sand returning into the hydrocyclone with the displaced water. The desanded water is now sent for further treatment, usually to de-oiling hydrocyclones. The sand can be either treated to remove any attached oil or stored for disposal.